Project 2.12 doesn't actually call for the use of technology at any point throughout it. However, it is a pretty lengthy project, and some of the graphing can become a little tedious, eat up class time. So what we want to take a look at is how we could integrate Desmos as a tool to speed this process up and give students more time to focus on sort of more of the meat of the problem versus spending additional time sketching graphs. In parts 1 and 2, we're asked to come up with a cost and a revenue function, and then in part 3, complete a table of values, and then sketch graphs of both of those functions. So we can do that by creating a table in Desmos. For context's sake, we could call this N1. We could call this C1 for cost and R1 for revenue. Actually, I take that back. What we'll do is actually input the cost and revenue functions that we would have found. So the cost function we would have found would have been 150 times N1 plus 8,000. And the revenue function would have been 350 times N1. So dragging that sidebar, we get a better view of each of those columns, and we can go ahead and input the given values for N. So we've already saved some time just on constructing that table of values, which you may or may not want to include depending on whether or not you're having students then graph those points by hand, because in part B then we're asked to sketch a graph of both of those functions. To do that, we can simply input each of those equations. We could call this C equals 150N plus 8,000, and R equals 350N. So now what we have are all of our data points being plotted for the cost function, the revenue function, and then we have the actual cost and revenue functions being plotted themselves. Every time we construct a new piece of our graph in Desmos, it kind of automatically assigns a color. So something we could do for clarity's sake is start to match some of these up. So we could change this first set of dots to red, so these points would all match our cost function, since these are our results from the cost function. And our revenue we could change to blue, so that what we're going to see is just that corresponding color combination between cost and revenue. We don't see a lot except for something that looks like a vertical line, but if we start to zoom out, in this case quite a bit, we'll start to see those points take shape, and if we just sort of manually zoom, we don't really get a very good view here because it's keeping our window square. So what we'll want to do is use that wrench icon to actually manually set some different values for our X and Y min and max. In this case, we'll set that to be 0 and 80, and then actually our Y min and max are set pretty well. So we've changed that viewing window or the viewing dimensions for our x-axis, and now we have a better picture of what these graphs should look like. So we have parts 3A and B completed, and then in part 4 we're going to be asked to use the graph to estimate our break-even point, or that point of intersection. So here we can click on either graph, we'll see that point of intersection highlighted in gray, and we get that value 40, 14,000, which in this case is an exact result versus an estimate. But then we can continue with the activity, manually solve that problem, algebraically solve that problem, and verify our result. In part 7, we're given a profit function, which we want to sketch. So one advantage of using Desmos is that we'll have this profit function overlaid with our revenue and cost function. So now in green we have our profit function, and what we'll be asked to do with that profit function is determine the intercepts of the graph. We can of course have students do this algebraically or manually, or we can click on this line in green and we'll see that those points in gray that will be highlighted will be our x and y intercepts respectively. So we would get our x-intercept of 40, 0, y-intercept of 0, negative 8,000, and then we can start to look at how we can start to answer what the meaning of each of those intercepts are. One thing that I like about graphing things this way is that we can see that that x-intercept is directly in line with the break-even point that we established in our cost and revenue functions. So graphing cost, revenue, and profit all on a single coordinate plane just gives us that additional visual representation of the similar meaning or the same meaning between those 2 points. Problem 8 then gives a new scenario with a new cost function, a revenue function that we would find in part A. And again, as an alternative to graphing by hand, we could repeat some of those same processes, just with the new equations to find the points of intersection.